Alright, so in the previous video we talked about how quadrant 1, which is filled out right here, is related to quadrant 2. Now, we're going to talk about how quadrant 1 is going to be related to quadrant 4. So, I previously filled out the information. Now keep in mind, cosine theta is the x value, and sine theta is the y value. So I did the same thing for all the given points, and I filled in the degrees. So, now, what we're going to do is see how quadrant 1 is related to quadrant 4, and I'll try to keep this video short and simple. Alright, just like in the previous video, what I do is I try to see connections to each given point. If they're directly related, then we can use the same values of the x and y from quadrant 1. So let's take a look at the one in red. That's 30 degrees. So coordinate point is square root of 3 over 2, comma 1/2. So again, this is my x axis and my y axis. So if I were to connect these two points, which I'm going to draw in red, so if I were to make the measurements and check how the distance are related, so let's see, I would say about 2 inches and 5/8. So here at least 2 inches and 5/8, 2 inches 5/8. So these two lines, the y-axis and the vertical line that I drew, are parallel. So therefore, if I were to connect from the point to the y-axis, these horizontal line that I'm drawing, if they are perpendicular to the y-axis, then they're also perpendicular here. So again, if these two lines are perpendicular, therefore these two lines are parallel. Same thing as here. If these two lines are parallel, then these two lines are perpendicular to the horizontal line. So basically, like a rectangle. Now, if the horizontal distance is the same as for the bottom to the top, and if the top, now, as I said before, is the same value as your x, because we're dealing with the horizontal, which is the x value. So this, my x1 is the same as this x2. Sorry, x1, my mistake. So if this is x1, then it will have the same value here. The bottom horizontal will have the same value as x1. So if the same horizontal distance, then I can safely say that the x-coordinate is square root of 3 over 2. Now my height from the center, which is my x-axis, so from here to this corner point right here, so where my two fingers are, that's my distance of my vertical distance, y1. So if this is the center, then meaning in the middle, then therefore if this side is the value of y1, then the other side, the other half, is also the value of y1. So if this is a vertical distance of y1, then I can safely say that the y-coordinate is 1/2. But keep in mind, we're in quadrant 4, meaning that the y values below the x-axis are negative. So instead of just positive 1/2, since we're dealing with y values below the x-axis, we have negative y values. So this is negative 1/2. So the coordinate is square root of 3 over 2, comma, negative 1/2. And to figure out the degrees, if we're using the same coordinate points, then the rotation here in quadrant 1 is 30 degrees, so therefore the one on the bottom, the amount is 30 degrees, but since we go in quadrant 4, it's negative. So since we're going clockwise, this is negative degrees, so the actual true degrees here is 360 minus 30, which is 330 degrees. So if you were to start from the standard position, which is this right here, the x-axis, or let me clarify, the right side of the x-axis, if I go 360 degrees, I stop right here, and that's our coordinate for cosine theta, cosine of 330 degrees, and cosine of 330 degrees. Alright, so let's talk about the second one, the 45, which is right here. So the 45, let me draw it. 45 degrees. So the coordinate is square root of 2 over 2, comma, square root of 2 over 2. So if I'm looking, this coordinate point right here is directly below that one, so let me connect those two. And if I were to check the measurements between the y-axis and the vertical line that I drew, it's about 2 inches and more than 1/8. 2 inches and a bit more than 1/8. 2 inches and a bit more than 1/8. 2 inches and a bit more than 1/8. So the distance between these two lines are the same, meaning that these two vertical lines are parallel. So if I were to draw a horizontal line between the y-axis and the coordinate points, so again, as I draw these lines, and if these lines, these horizontal lines, are perpendicular to the y-axis, then they're also perpendicular to the vertical line that I drew. So these two vertical lines are parallel, these horizontal lines are parallel. Then, if that's true, then my horizontal line, so I'm using this coordinate point from quadrant 1. My horizontal line from the y-axis to the coordinate point is the distance of my x-coordinate, x2. And my x2 is square root of 2 over 2. So if these two lines are parallel, and the same distance between these vertical line, then what my x value, or the value of x2, will be the same at the bottom horizontal line. So over here would be also x2. So if my x2 value is square root of 2 over 2, then it would be the same over here. So I can safely say my x coordinate is square root of 2 over 2. Now, if my x-axis is the center, so on my horizontal line, if this is the center, the top half and the second half, so keyword half, then they're the same measurements. So from the center, the x-axis to the coordinate point, the vertical distance is the value of y2, or y sub 2, because it's different from y sub 1. So the value of y sub 2, so from the x-axis to the top point, if this is the top half and this is the bottom half, keyword half, then they're the same measurements since the x-axis is directly in the center. So I can say that the bottom vertical line is also the y sub 2. So then the value of y sub 2 is square root of 2 over 2 from quadrant 1. Then I can write this in quadrant 4, square root of 2 over 2 for the y value. Now, keep in mind, since we're in quadrant 4, our y values are negative, so our true y value of this point right here is negative square root of 2 over 2. Now, if I want to figure out the positive angle measurement, so from my x-axis to this angle right here, since I'm going clockwise, it's going to be negative 45 degrees. So that's negative 45 degrees. I'm going to do 360 minus 45 degrees, which will be 315 degrees. So if I start from my standard position and I rotate 315 degrees and stop here, then my cosine of 315 degrees is square root of 2 over 2. My sine of 315 degrees is negative square root of 2 over 2. Alright, so let's talk about the 60. So I'm going to draw our 60. Alright, so using the same process, the same concept, I'm going to connect these 2 points together with a vertical line. So, and always check if it's equal distance between these two lines. So, an inch and a half, about an inch and a half, about an inch and a half, and about an inch and a half. So, equal distance here, equal distance here, equal distance here, equal distance here. So these two horizontal line that the horizontal line I drew and the y-axis are parallel. So if I draw our horizontal line connecting from the one I drew and the y-axis, alright, if these two horizontal lines I drew are perpendicular to the y-axis, they are perpendicular to the vertical line that I drew. So, if it's equal distance between these two lines, the y-axis and the one I drew, if they're parallel, meaning they're equal distance, then my top half, the horizontal line I drew, is the same value as my bottom line that I drew. So if my top horizontal line that I drew is x3, then I can say that at the bottom half, right here, is the same value as x3. So, since x3, the x-coordinate, is 1/2, then over here, I can safely say that this is also 1/2, because they have the same x values. Now, if the x-axis is in the middle of the black vertical line I drew, if that's in the middle, then the top half of the vertical line is the same distance as the bottom half. So if the top half is y sub 3, then the bottom half is also the same value as y sub 3. So y sub 3 here, y sub 3 here. So then that means that I can put the value of y sub 3, which is square root of 3 over 2, which I got from here. But remember, since we're in quadrant 4, we're dealing with negative y values. So the true y value at this point is negative square root of 3 over 2. So, now since we're dealing with 60-degree angle in quadrant 1, this is also 60 degrees, but negative because we're going clockwise. So that's negative 60 degrees. So, if this is negative 60 degrees, I'm going to subtract from here 360. So 360 minus 60 degrees. So our true or our positive angle measurement is 300 degrees. So if this is 300 degrees, so if I start from my standard position right here, and I rotate 300 degrees, I'll stop right here at this angle. So cosine of 300 is 1/2. Sine of 300 is negative square root 3 over 2. Now, if I'm trying to figure out the angle measurement of this one, so starting from my standard position, or 360 degrees, I rotated 90 degrees clockwise, so negative 90. So if I'm going quadrant 4, I'm rotating negative 90 degrees, or 90 degrees clockwise. So I'm going to do 360 minus 90, which right here will be 270 degrees. So that's 270 degrees. So if I start from my standard position, if I rotate 270, I'm going all the way to this y-axis. But if I'm going negative 90 degrees, I'm rotating clockwise 90 degrees and stop at 270. If I'm going 90 degrees clockwise, I'm just going clockwise and stop at 270 degrees. Now keep in mind, when we did cosine of 90, which is 0 for the x-coordinate, and we did sine of 90, which is 1 of the y-coordinate. Now keep in mind, this is the y-axis. So you see how it's a straight line. So if this is the center, then my distance from the center to the top point is the same value as from the center to the bottom point. So since we're dealing with the y-axis, the vertical line, if the distance from the center to the top point is 1, then it will be the same as the bottom half, so it's going to be 1. But remember, since we're dealing with the the y-axis below the x-axis, then we're dealing with negative y value. So this, instead of positive 1, it will be negative 1. And you see how we're in the horizontal asymptote? The y-axis. So that means that if it's a straight line, if this is the y-axis, then we're dealing with the same x value. If the x value is 0, then it would be the same here. So our x-coordinate is 0. So if I were to rotate 270 degrees, I stop right here. So my cosine of 270 degrees is 0. My sine of 270 degrees is negative 1. So we figure out the points for quadrant 4. So what I'm going to do is zoom in. So if you want to copy this down, so cosine of 330 is square root 3 over 2. Sine of 330 is negative 1/2. Cosine of 315 is square root 2 over 2. Sine of 315 is negative square root 2 over 2. Cosine of 300, 1/2. Sine of 300, negative square root 2 over 2. Square root 3 over 2. And then cosine of 270, 0. Sine of 270, negative 1. So there's the exact values of quadrant 4 for 270, 300, 315, 330.